Okay, so in previous session, we had some question related to light. So meaning of question, which is describe one example of how optical fibers are used in medicine. So you already know about the concept of endoscope. So we need to explain with the reference of endoscope, right? That we use endoscope in medical field and to detect the internal organ or to detect the internal disease, right? Or for the internal treatment of the body, right?
Yes.
Okay. Question 5. A glass converging lens is used as a magnifying glass to observe a red ant. Figure 6.1 shows the lens. Principal axis to principal focus f1, f2. On figure 6.1, mark a point on the principal axis labeled A to indicate a suitable position for the ant. So we need to find mark a point on the principal axis labeled A.
On F1?
On f1 or between f1 and lens. Because object is
Mm,
very small, so or you can say that object is very tiny, so we have to place the object according to the size of the object. So we have to place between f and convex lens because object is very tiny and we need to observe that object or that ant with highly magnification. So that's why we have to place between f1 and the lens, right? Let's suppose over here, and this is A, right? And on figure 6.1, mark a point on the principal axis, label E to indicate a suitable position for the observer's eye.
on the right hand side?
On the right hand side, tick one of the box to indicate where on the principal axis the image of the ant is located. So we have to tick one box,
To the right of F2?
the right or to the left, because we place object between F and lens. So in this condition, we know that we observe or we will get the virtual will on the same side because we have to find out or we have to observe magnified. Magnified. It means we are getting the image of object on this side that is on the left hand side. It's highly magnified. So this will be image. So it means that we are getting image to the left of F1, right?
Yes.
Now they also ask about the property. So we know that we are making vertical here and it is upright. Real inverted diminished are not possible. Image is virtual, upright, and magnified. Okay, so the red light from the ant passes into the lens. As the light enters the lens, state what happens to its wavelength.
Wavelength becomes greater?
Okay, so now it is passing into the lens. As light enters the lens, so state what happens. So wavelength will be greater.
Will it be the same?
For frequency, it will remain same. But if we talk about the wavelength, so wavelength will decrease in the lens or the light which is moving from, if you remember the concept of prism, so with the same concept, we know that light will bend. So during the refraction or during the bending process, the wavelength will decrease, right?
Okay.
Because if we compare the density of ant and the lens, so the density of both objects will be different. So the density of ant will be greater than the density of the lens. So it means that light is moving from dense to rare in comparison. Because if we compare ant and the lens, so density will be different. Now we are not comparing from air to dense, right? And state how the wavelength of violet light in air differs from the wavelength of red light in air. Now they are talking about the concept of air. So if
The wavelength of violet light is greater?
greater or smaller,
Smaller.
because if you remember the concept of prism, so in prism we draw on the right hand, and red light is and violet light on the bottom. So it means the wavelength of the red light is greater. That's why it will be on the top side, wavelength of light. And if you also remember that chart of electromagnetic spectrum, so on left hand side we are getting gamma rays, X rays, UV rays, right? That's it. UV, gamma, ultraviolet, X-rays on left hand side, and in the middle we are getting on the right hand side. So we are getting microwaves, radio waves, infrared rays. Remember that diagram?
Yes.
So according to that diagram, when we are moving on right hand side, length increase, and if moving on left hand side, so frequency. So it means ultraviolet or violet color is on left hand side, red color is on left hand side, and red color side. So it means red color or the wavelength of red color is greater than the wavelength of violet color, right?
Yes.
So it means wavelength of violet color is smaller than the wavelength of, okay.
Yes.
Question 6, figure 5, figure 7.1 shows a convex lens behind being used to produce an image of an object. Uh, ob an image is already mentioned on the diagram. Place three ticks in the table that describes the image. So what is the first property of the image? Is it real?
Virtual?
It is virtual. It is magnified. It is upright. So virtual, up, enlarged. So these are three ticks which we have to mark on the table. Okay, now on figure 7.1, mark a letter E to indicate a possible position for an eye to be placed to observe the object. So again, we know that we have to place eye on
Right hand side?
the right hand side. State an application in which a convex lens is used in this way. So what is the application in which we are
Magnifier?
magnifier or magnifying glass, right? Telescope, microscope. So multiple options are there. We use this in magnifying glass, or we also use in microscope. we may also us in this scope, right? So multiple options are there. And in space below, draw a diagram to locate the image of an object of height 1 centimeter, place 5 centimeter from a convex lens of focal length 2 centimeter. Draw your full size diagram. You are advised to locate the lens roughly in the center of the space. Label the image. So now you have to the image with accurate observation. So it means that we have to mark the diagram with accurate reference. So have to use the ruler. So that will help you to mark diagram with exact marking which is mentioned on the diagram, right? Okay, so first of all, we need to draw lens in the center. So let's suppose we are having a lens in the middle. I'm drawing straight for the lens. Okay. So this is the position of the lens. And again, we have to draw a principal axis in the center. So this is the principal axis in the middle. According to the specification which is mentioned in the question, that draw a ray diagram to locate the image of an object of height 1 centimeter, place 5 centimeter. Focal length is of 2 centimeter. So it means that according to 2 centimeters, I'm using ruler to identify the exact position. So 2 centimeter will be marked over here. So this is 2 centimeter. And we also mark the 2 centimeter over here. And this will be 2F. Okay. So we are having values of F and 2F. So this is F, exactly 2 centimeter from the lens, and this is 2F, exactly 4 centimeter from the lens. This is again F on left hand side. This is again 2F on the left hand side. And now object is placed 5 centimeter from the lens. It means 1 more centimeter from the lens. It means that object is placed over here. So this is 5 centimeter. And the height of object is 1 centimeter. So that is exactly 1 centimeter. Okay.
Yes.
So we are having object over here of 1 centimeter height and 5 centimeter from convex lens. And now we have to draw the image. Okay, so again we know that we have to draw two lines. One is moving straight from or parallel from the object to the lens, and then passing from the principal focus like this. And the second ray will pass from the center, straight from the center like this. And if you remember the property, when object is placed beyond 2F, So image will be formed between f and 2f, right? Remember that property?
Yes.
So this will be the size of image. And the size of image will be smaller than the size of the object because object is placed beyond 2f, right?
Yes.
So we know that we are getting image is smaller in size and we are having real inverted smaller in size or diminish image on the right hand side. So this is the concept to draw the image with exact or accurate measurement given in the question, right?
Okay.
Okay, further moving on to the next question. Okay, this question is also like the previous one. The diagram shows a diagram, ray diagram of the convex lens. On figure 8.1, label the object O. So where is the object? We have to mark O. So this is object O. This will be image I. Place a label a principal focus. So this is a principal focus, right?
Yes.
Put arrows on the two rays to indicate their direction. So that is also simple. We are moving in forward direction first. Then we actually draw the back and side, right? So that is the identity diagram. Very simple. And figure 8.2 shows a ray of light in air incident on an interface with glass. The refractive index of glass is 1.5. On 8.2, accurately draw the ray as it travels into glass. You will need to take a measurement from 8.2 and carry out an appropriate calculation showing your working. So now we have to solve with complete calculation with the reference of diagram. So it means that we have to find the angle with respect to the diagram or with the reference of diagram because values are not mentioned over there. So what we have to do now, first of all, we need to draw a normal over here to measure the angle. So this is the line, okay? So this we have to find out the angle of incident over here. The angle of incident. So we have to measure the angle of incident and that can be calculated with the help of protractor over here. So we have to place protractor over here to find out the angle. So if you place protractor over here on the screen, so that will also help you to find out the angle. Okay, screen is visible now.
Yes.
So this is diagram we are using in our question. So we already marked the angle of incidence with reference to the normal and so it means that this is 0 degrees and now we have to find out the angle. So if we start and place with the accurate measurement. So that gives you the angle 55, right? So 55, right? Again, come to our original questions. So this angle, it will be equal to 50 from the surface. So angle of incidence will be 9 minus 55, that's 35 degrees, right?
Yes.
So it means the angle of incidence is 35, and easily calculate. So equals to sine divided refraction, because now we are moving from rare to dense, and R will be equal to sine 35 divided by 1.5.
22.4.
22.4. Okay. So 22.4 degree angle of refraction, right? Okay, so the refractive index of a type of glass is 1.6. Calculate the critical angle for light in this type of glass. So we have to find the critical angle, and you remember the formula 1 over C, right?
Yes.
So again, we have to find out the value of C, so that we equal to C is equals to 1 over, sorry, sine inverse equals to sine inverse 1 divided by 1.6,
It's 56.3.
56.3. Okay. A waterproof laser is immersed in water, shows the laser shining light up towards the horizontal surface of water. So now we are moving from dense to rare. Movement of laser, beam of light are mentioned on the diagram. Initially, the angle is much less than the critical angle for this light in water. So now angle is less than critical angle. The laser moves and theta gradually increase until it is much greater than the critical angle. So now angle is greater than the critical angle. For describe for different angles of the laser what happens to the light beam after it hits the surface. So we have to explain the whole phenomena of total internal reflection, right? So initially, angle when is less than the critical angle, right? Angle is less than the critical angle. So, right, in air, we move from dense to rare medium, from water to is that light will reflect in the air surface, right? And second, when the angle is most equal to critical, right? Not exactly equal to, less or equal to critical angle. So we know that some light will start refracting and some will reflecting. Indication of reflection of light, and the third angle is equal The critical angle, light will refract at 90 degrees. And the last point, angle is greater than critical angle. So what will happen?
Light ray will go total internal reflection.
Yes. Completely into the same medium. Okay. So this is the answer of part B, right?
Okay.
So now try to solve the remaining question. I hope now that will be easy for you to solve the question because now questions are not typical, but maybe some confusing in finding the angle or type of question. But try to solve the questions and we will continue with the remaining question if you find difficult, right?
Okay.
Okay. So in next class, we will continue with another topic that will be difficult in solving the question. So try to solve the wave section till now. So we will continue with the next section, right? Because we have to cover the thermal also. We have done two chapters. We have to complete the third one. So tomorrow we will start with the question of the thermal physics, right?
Okay.
Okay. Last is